Hello, my name is Dr. Gleisner, and today we're talking about mixtures very quickly. So a mixture consists of two or more elements or compounds not chemically combined together. So, for example, if you have air, then you know you've got nitrogen mainly, and you've got some oxygen, and the oxygen is floating around, and the nitrogen is floating around, and they're not chemically bonded. Now, oxygen looks like this. Oxygen has two oxygen atoms, and these two lines in between them means that they are chemically bonded. That is actually an interaction that is very, very hard to break. Nitrogen is even worse in that respect because it has three bonds. That's very unusual in nature. Having three bonds, most things have just one or two bonds between them. So nitrogen is very, very unreactive because you have to essentially break through all of these three bonds. Oxygen is sort of meh. Reactive because actually the first of the two bonds can be split by UV light or other forms of energy, and also if it just if there is a spark or enough energy in it collides with a fuel source, then you can have fire. However, in between these molecules there is a tiny little force, and these lines here are supposed to just indicate a sort of, they're not a solid line. So a solid line would look obviously like this. They're not a solid line. So what that indicates is some sort of weak interaction between the two. You can imagine it's like a really weak tractor beam. And as those two particles approach, they most likely sort of attract each other in a very fleeting way, in a very short way, and then they bounce again, and so they come together, and then they separate again after a while. So if we want to do like speed lines on them, they come together, there you go, they're sort of attracted initially, and then they come together, and then they separate out again. Okay, so you can have a mixture of things that are not chemically combined. So a very straightforward example would be if you've got a beaker of rice and peas. So you've got grains of rice there, and you've got peas in there, and you can it'll take some work, but you can sort them out. A more chemical example of that would be if you have a salty solution. So you've got a solution of salt and water. So there's water in here, and in that water you've got salt. We call that brine if there's quite a lot of sodium chloride in there. And what you can do is you can leave it to stand, and after a while the water evaporates. So the water evaporates, and what you're left with is just the salt crystals. Okay. Now this is some time later, obviously. So the water has all gone, evaporated, and that would have been a mixture because the salt is not chemically combined with the water, and we call this we call the water in this case a solvent, and the water is a solvent, and the whole thing is a solution. And the thing that was originally dissolved in the solvent was the solute. Okay, so later on we'll talk about a little bit more about that. Mixtures can be separated by simply physical processes. So what we've learned in the previous video is that if you've got a compound like H2O with like little numbers, and you always see the little numbers unless it's a 1, so there's not a 1 there really, then you cannot break this up by purely physical processes. Now, strictly speaking, that's not true, but what we mean for our purposes is things like filtration, crystallization, simple distillation, fractional distillation, and chromatography. Electrolysis and heating until molecules break up is creating a plasma potentially. That's not what we mean by physical processes in our case. But just be aware that you can, of course, break water into its constituents. It's just not considered physical purely, because you're not making something new. You're manipulating the things that are already there. You're making them turn into a gas or liquid or something like that, and you're separating them out like this. Students should be able to describe and explain, it says. So this is the bit. This is the bit that I've just read out. So filtration, crystallization, simple distillation, fractional distillation, and chromatography. And we will talk about that a little while later and maybe do some experiments. These physical processes do not involve chemical reactions, and no new substances are made. So good. Students should be able to describe, explain, and give examples of the specified processes of separation. In other words, you need to explain what is meant by that. And I will do this in the next video because I want to keep this as short as possible. And if you're already happy with crystallization and so forth, you don't need me to talk about it. And then suggest suitable separation and purification techniques for mixtures when given appropriate information. So for example, in this example here, you're making crystals, and that is a type of crystallization, although not exactly what chemists mean when they say crystallization. But as promised, I'll explain that in the next video.